So this is where we're going to start off today. Yep, starting off here. So we have this one and two more. I added one, but that's just to show an example or show just a certain type of problem that will come up, especially on the homework. So, yes. From Tuesday, yes. Now, first thing we need to do with any of the solving is to make sure all the denominators are as factored as simply as possible. We need them all factored as far as possible. Yes, and the x, yes. Our x squared minus 4 is a difference of perfect squares, so it'll factor to x plus 2 and x minus 2. And that helps us make sure we don't have any additional factors when multiplying through. Restrictions. The two places where we cannot have x be 0 in those denominators is with x plus 2 and x minus 2. With our x plus 2, we'd subtract 2, telling us that x can't be negative 2. With our x minus 2, it tells us that when x is positive 2, they make one of the denominators be 0, so x cannot be 2 or negative 2. If we get one of those two, just like we saw on Tuesday, we have to throw that solution out. Incidentally, if we go and check our restrictions and we see that every solution that we have is a restriction, then it's going to be no solution. We threw all the solutions out, none of them actually work. So that's a little different with this here, unlike most, where we have a no solution, it's just we don't have any values, none show up. Here we can get solutions, but because they are restrictions, we can end up getting no solutions, even though we actually solve and get an answer. It's just that answer doesn't work. Now looking at this here, we need to see what we need to multiply through by to get the fractions to go away. So what's one thing we're going to have to multiply through by? X plus 2 and x minus 2. And let's see here, so x minus 2 and x minus 2 will cancel. X plus 2 and x plus 2 will cancel. And here, both will cancel. So multiplying through by 1x plus 2 and 1x minus 2 did simplify every denominator. So that's all we need. And what we're left with is 9 times x plus 2 plus 6x times x minus 2 is equal to 9x squared. So the far side, our third rational expression, just simplified to the numerator, which is kind of nice. Questions on this so far? At this point here, we can distribute. 9 times x is 9x. 9 times 2 is 18. 6x times x is going to be plus 6x squared. And 6x times negative 2 is going to be negative 12x. Yes, 9x and negative 12x are like terms, so we'll still have 6x squared minus 3x plus 18 is equal to 9x squared. Yes, now we will need to get it equal to 0 because we do have those x squared terms, or x squared. So we subtract it, telling us that we have negative 3x squared minus 3x plus 18 is equal to 0. Now we can solve this by factoring. All but 2 on the homework are going to be factorable. All the ones on the test will be factorable. Yes. More specifically, I'd factor out a -3. And the reason I do -3, because if we're going to factor it, I want the x squared term to be positive. I want the number in front of x squared to be positive. It's going to make factoring it nicer. So factoring the negative out is going to flip all of our signs. So x squared is going to go from negative to positive. X is going to go from negative to positive. Our constant term 18 is going to go from positive to negative. And then we'll have x squared plus x minus 6. Now, incidentally, since we factored out a number, our greatest common factor was a number, we really could have divided it. We could have gotten rid of that 3. And there's a reason for it, because here I have -3 times our quadratic. I have two things multiplied together that equal what? 0. One of them has to be 0, yes? Is there any way I can plug a number in and make the 3 be 0? Well, no, there's no variable with it, it's just 3. So really the only thing that could be 0 for this is this here. We can get rid of that -3. But we'll leave it there since we have it written out front. 2 sets of parentheses with 3 spaces. Our signs would be opposite. Our factors of x squared are x and x. Now our factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Where? Positive 2? Positive 3, yes. And those would be the correct factors. So we're saying that x plus 3 is 0 or x minus 2 is 0?
Yeah, x is -3 and x is positive 2. Positive 2 is one of our restrictions.
Yes. Solve. X is equal to -3. X is equal to positive 2. Well, we have to throw out the positive 2 because, again, yes, it is a restriction. It would cause one of the denominators to be 0. Actually, it would cause two of them to become 0. So it doesn't work. It is a solution. It's an extraneous solution. So it works, and it is an answer from our solving steps, but doesn't work in the original context. And extraneous solutions do show up in lots and lots of different places. It's not something that just shows up here. Questions on this here? All right. Now, if the numerators are factorable, don't factor them. It doesn't make any sense. I mean, you can do it, but in our solving steps, because you can factor it, but then we're going to have to immediately unfactor it to be able to combine like terms and solve. Excuse me. So having the numerator factorable doesn't make a whole lot of difference one way or the other. The only reason that we would factor the numerator is if the numerator and the denominator in one of these rational expressions shared a common factor, and that common factor on top and bottom was not shared in the other two. So here we have x plus 1 and x minus 1. So if the third one had x minus 2 over x minus 2, only place it shows up, so removing it from there is not going to impact the rest of the problem. So it's almost one of those situations that's a rare occurrence, probably is not going to show up. Yes. Or x equals 0? Yeah. Because 0 is a number, so it works. So let's look at this here. So the x squared minus x minus 2 is going to factor to x minus 2 times x plus 1. Restrictions. X plus 1 can't be 0, x minus 1 can't be 0, and x minus 2 cannot be 0. So this time we actually have 3 restrictions. It can't be positive 1, negative 1, or 2. So if we get any one of those 3, we have to throw that value out. And again, that's nice because it just takes a few minutes to do that there. Where on the other side, if we don't look at the restrictions or talk about them, any and all solutions I get, I have to put back into the equation to make sure they work. To get, or pretty much to find if it is a restriction or not. Now, x plus 1, x minus 1, x minus 2. Now I do this here multiplying at this kind of angle so that we don't have to rewrite out the whole thing and have those sitting next to it. It's a nice way to do that. But do be careful to make sure you don't lose track of these factors we're multiplying by, because it is very easy to drop one of these and it's going to change how the whole problem works. So what we're left with is 2 times x plus 1 times x minus 2. The middle is going to be x minus 1 times x minus 2 is equal to x minus 1. Yes. Now when we distribute, especially with this first one here, you can multiply the 2 by one of the 2 sets of parentheses. We can't do both. Or do the parentheses first. I would suggest doing the parentheses first. We'll worry about the 2 here in a minute. X times x will give us x squared. X times negative 2 is negative 2x. 1 times x is plus x, and 1 times negative 2 is negative 2. Other x times x is x squared. X times negative 2, negative 2x. Negative 1 times x is negative x. And negative 1 times negative 2 will give us positive 2. Combine like terms. We'll distribute the 2, giving us 2x squared minus 2x minus 4, plus x squared minus 3x plus 2 is equal to x minus 1. Before we get it to 0, we do need to combine some like terms. X squared plus 2x squared is going to give us 3x squared. Negative 2x minus 3x is going to give us negative 5x. And negative 4 plus 2 is going to give us negative 2. Questions on this so far? Now we need to get this equal to 0 so we can add 1 and subtract x. Spin that up. All right. I will tell you this here, that doesn't factor. No, there's no way we can use the factors of 3 and 1 and somehow get 6. It's just not going to work. And especially since the third term, our 1 is negative, which means the signs are opposite. So it's going to be working against it. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This should be familiar. It's been a while since we've had to use it. This is the quadratic formula. And it does match up with our ax squared plus bx plus c. So for us here, A is 3, B is negative 6, and C is negative 1. So we have negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times negative 1 all over 2 times 3. I'm going to get my calculator. Now, luckily for us, once we get it in this form, the rest of this is not so much calculating as much as it is simplifying. Our first one, negative 6, is positive 6. On bottom, 2 times 3 is 6. At this point, I'd grab the calculator and say negative 6 squared minus 4 times 3 times negative 1, 48. So we get 6 plus or minus square root of 48 over 6. Like we can take the calculator, say second square root 48 is 4 square root of 3. Now, for the most part, I will take this here as your answer, as your final answer for this. But it can be simplified. So the 6 and 4 on top and the 6 on bottom all share a common factor of what? 2. So we can factor the 2 out of the top, which will give us 3 plus or minus 2 square root of 3. And we have to factor it out of the bottom, which is also going to reduce to 3. Essentially, we pull the 2 out of the top, pull the 2 out of the bottom, and the 2 over 2 reduce. And especially if you've seen or looked this up, or some sites, when they solve this, they will break it up even further. Into this here. Because what they did is they split the fraction into 2 parts. The first part is going to end up being 3 over 3. Well, 3 divided by 3 is our 1. Plus or minus 2 and the 2 square roots of 3 over 3. That's not going to reduce, so we just have plus or minus 2 square roots of 3 over 3. Is that any simpler than the answer we had? No. So, that's all we need. Is that one of our restrictions? No. So both of those work. So there are going to be 2 problems on the homework that require you to use the quadratic formula. And I will tell you this, the numbers inside that radical are decently big. I think one's 100 and something. But if you are able to reduce it and see that it reduces on 1 or 2 of them, reduce it. If not, I will take it in non-reduced form. Questions on this here? There's one more I'm going to do. I want y'all can watch this. It's not in the notes. So this problem here, I'll tell you that, so x squared minus 4 factors x plus 2x minus 2. We feel good about that there. That also means that the restrictions is that x cannot be positive or negative 2. So to solve this, the first thing we're going to do is multiply by x plus 2 and x minus 2. Incidentally, what that leaves us with is 8 times x plus 1 is equal to 2 times x minus 2. Luckily for us here, this is kind of nice. We distribute the 8 and get 8x plus 8 is equal to 2 times x is 2x minus 4. Minus 8 from both sides, so minus 8x is equal to 2x minus 12 minus 2x, telling us 6x is equal to negative 12. Divide by 6, so x is negative 2. But that's one of our restrictions, so that doesn't work. Do we have any other solutions left? No, so this is no solution. Because we did get a solution of negative 2 for this, but because it makes the denominator be 0, we have to throw it out. Since we threw out every solution we have, there is none. There's no solutions that work for this. That's it, 23 through 26, 29, 30. 29, 30 are the two that you're going to have to use the quadratic formula for. 29 and 30.